Picture this. Nvidia just announced the highest revenue in its history, $57 billion in a single quarter. That's almost $20 billion every single month. The CEO takes the stage, celebrates their Blackwell chips flying off the shelves, and then something strange happens. The stock crashes. Major investors start selling. The company exceeded expectations, but Wall Street acts like they just received terrible news. This isn't just a stock market oddity. This is a signal that something fundamental is shifting in the world of artificial intelligence, and the implications go far beyond one company's share price. In this video, you're going to discover why the strategy that created ChatGPT and every other major AI breakthrough might be reaching its limits. You'll learn what 3 of the world's leading AI researchers are saying about the future of these systems, and you'll understand why we might be standing at the most critical turning point in AI history, a moment that will determine whether the technology explodes into something far greater or stalls in ways that could cost the industry hundreds of billions of dollars. But before we dive in, let me share something with you. A few months back, I started creating these videos from complete scratch. No background in production, no fancy gear, no crew. Just one person determined to explore AI and technology in a way that actually makes sense. Make sure you like this video and subscribe to see new videos like this. Now, let's dive in. Imagine you're driving on a long, straight highway. For years, you've been doing the same thing, pressing the accelerator, going faster and faster. The road ahead is clear, and speed is everything. More data, larger models, more computing power. This simple formula worked like magic. Every time you scaled up any part of this equation, the AI systems got dramatically smarter. They call these scaling laws, and for the past 5 years, they've been treated almost like laws of physics. When OpenAI jumped from GPT-3 to GPT-4 to GPT-5, each leap brought capabilities that seemed impossible just months earlier. The pattern was clear and reliable. Want a smarter AI? Make it bigger. Feed it more data. Give it more processing power. Repeat. But now, something's changed. The highway doesn't look so clear anymore. There's fog ahead. Some people see it as just a curve in the road. Others think it's a concrete wall. And some believe it's an intersection, leading to an entirely different route. We don't know exactly what's beyond that fog, but we can see that the old strategy isn't working the way it used to. And the people saying this aren't random critics or skeptics trying to get attention. They're the architects of the systems we're using today. Ilya Sutskever is probably a name you've heard before, usually in the context of the drama at OpenAI when he voted to fire Sam Altman. He lost that fight, Altman came back, and Sutskever eventually left the company. But here's what matters. Sutskever is the co-founder and former chief scientist of OpenAI. He's one of the people who built GPT-3 and GPT-4. He understands these systems at a level few people on Earth do. At a conference last year, Sutskever made a striking comparison. He said that data is the fossil fuel of AI. We only have one internet, and we've reached peak data. There will be no more. Think about what that means. The internet is the largest collection of human text in history. Every tweet, every blog post, every Wikipedia article, every forum discussion. Big tech companies have mined this data like oil, with or without permission. And they've used it to train every major AI model we use today. But the internet isn't infinite. And according to Sutskever, we've essentially used it all up. Last week, he appeared on a podcast and said something even more direct. From 2020 to 2025 was the age of scaling, he explained. But now the scale is already so large. Would everything really be that different if you had 100 times more? I don't think that's true. We're entering the age of research again. This is a massive admission. The person who helped create the scaling paradigm is now saying that simply making things bigger won't be enough anymore. But he's not alone in this assessment. Yann LeCun is Meta's chief AI scientist and a Turing Award winner. That's essentially the Nobel Prize of Artificial Intelligence. He won it in 2018 alongside Joshua Bengio and Geoffrey Hinton, who's often called the godfather of AI. for their pioneering work in deep learning. He's now speaking even more bluntly about the limitations of large language models. LeCun believes these models are a dead end on the road to human-level intelligence. He's not saying they're useless. He's saying they're fundamentally limited. No matter how big you make them, they can only learn statistical patterns in text. They don't actually understand the world. LeCun uses a provocative example. Even a house cat understands the physical world better than these AI systems. A cat knows it can walk through an open door. It understands that objects don't disappear when they're hidden behind something else. It can plan complex movements through space. Current AI models, despite all their impressive language abilities, lack this basic grasp of physical reality. At the World Economic Forum this year, LeCun went even further. He said no one in their right mind would use large language models as the central component of an AI system anymore. Those are harsh words from someone who spent his career building these technologies. LeCun isn't just criticizing. He's proposing alternatives, like world models. He argues that AI needs to learn not just from text, but from interaction with the physical world, like how a baby learns, by touching, seeing, and experiencing reality directly. Sutskever said something similar in his recent podcast appearance, talking about how human emotions and physical experiences are fundamental to real intelligence. He pointed out that while we've made progress in newer human abilities like mathematics and language, we've been fooled into thinking that's all intelligence is. But for most of human history, our intelligence developed through vision, hearing, and movement through physical space. And current AI systems can't really do that. Then there's Gary Marcus, a cognitive scientist from New York University. Marcus has been called a professional pessimist because he's been warning about AI limitations for years. Back in 2022, he wrote an article titled, "Deep Learning is Hitting a Wall." Sam Altman indirectly criticized him at the time, and many people dismissed his concerns. But Marcus hasn't given up. He's continued to argue that hallucinations, when AI systems make up false information, cite sources that don't exist, or describe events that never happened, aren't bugs that can be fixed. They're features of how these systems work. According to Marcus, there's no principled solution to hallucinations in a system that works purely on language statistics. The AI doesn't understand truth because it's fundamentally just guessing the next word based on patterns. No amount of scaling will fix that. So we have three different perspectives, but they're all pointing in the same direction. The strategy that got us here won't take us much further. And this brings us back to Nvidia's strange stock market reaction. Nvidia's record profits come from the money that big tech companies are pouring into AI infrastructure. Amazon, Microsoft, Google, and Meta are collectively investing over $400 billion per year into AI. That money goes toward data centers, specialized chips, and energy infrastructure. But investors are starting to ask a critical question. Will these investments actually pay off? If AI really has hit a wall, if scaling isn't as effective as it used to be, then what's the return on these massive expenditures? Even OpenAI, which positions itself as the leader in this field, doesn't expect significant profits until 2030. That's another 5 years of burning money. Nobel Prize-winning economist Darren Acemoglu has warned that these models are overhyped and we're overinvesting. There's also an interesting pattern in how money flows through the AI ecosystem. Nvidia invests in OpenAI. OpenAI leases computing power from CoreWeave. CoreWeave buys chips from Nvidia. Everyone's pouring money into everyone else. But how much real end-user demand is there? Most people pay $20 per month at most. Some pay $200, but they're a tiny minority. Famous investor Michael Burry, the man who predicted the 2008 housing crisis and was portrayed in the movie The Big Short, has now taken a position against the AI sector. He's calling the real end-user demand ridiculously small and saying that nearly all customers are financed through venture capital. On the other side, Jensen Huang, Nvidia's CEO, completely rejects the bubble narrative. He says this isn't speculation. It's a fundamental technological revolution. According to him, Nvidia chips are essential infrastructure for cloud computing, AI products, an enterprise software transformation. He describes it like this. In the past, software was compiled once and then run repeatedly. Now, every AI request needs to be generated fresh in a factory. Nvidia provides the infrastructure for those factories. But here's an interesting counterpoint. When Google recently released Gemini 3, their latest AI model, it immediately shot to the top of the performance rankings. And guess what it doesn't use? Nvidia chips. Google developed their own processors called TPU, and they're running Gemini 3 on those instead. That doesn't mean Nvidia has lost the race. They're still dominant. But it shows that the landscape is shifting. So what's actually happening here? Is AI a bubble about to burst? Or are the skeptics missing the bigger picture? The truth is, probably somewhere in the middle. Here's what the evidence suggests. First, large language models are likely approaching the limits of pure scaling. Making them bigger won't produce the dramatic leaps we saw in previous generations. Sutskever, LeCun, and Marcus are all saying this from different angles, but they agree on the core point. Second, this doesn't mean AI is finished. It's not even necessarily the end of large language models. It's the end of the assumption that bigger automatically means better. Researchers are already exploring different approaches. Synthetic data generation, world models that learn from physical interaction, and hybrid systems that combine multiple techniques. Third, the market's caution makes sense. The return on hundreds of billions in investment isn't clear yet, but that doesn't mean the money was wasted. It means expectations got ahead of reality, and now we're entering a correction period. There's a useful historical comparison here. The dot-com bubble of the early 2000s. Internet companies inflated to absurd valuations, and then the bubble burst spectacularly. But did the internet disappear? No. It's still the foundation of our digital world. It fundamentally and irreversibly transformed society. And in the years after the bubble burst, the truly dominant platforms emerged. Google, Amazon, Facebook. They rose from the ashes of the bubble. AI might follow a similar path. The word bubble refers to inflated valuations of specific companies and business models, but that doesn't mean the underlying technology is useless. What's happening now is a maturation process. The narrative of AI as a magic tool that will solve everything is fading. In its place, we're developing a more realistic understanding, powerful technology, but with clear limitations. And maybe that's actually healthy. Exaggerated expectations lead to disappointment and wasted resources. Realistic expectations enable sustainable progress. As Sutskever said, maybe the age of scaling is over, and we're returning to the research lab. And historically, that's where the most interesting breakthroughs happen. Not when everyone's following the same obvious path, but when people are forced to find new routes. So, has AI hit a wall? In a sense, yes. The old highway is ending, but walls can be climbed over, gone around, or broken through. The question isn't whether progress will continue, it's what form that progress will take. The age of simply making things bigger is probably over. The age of figuring out fundamentally new approaches is just beginning, and that might be exactly what we need. If you found this perspective valuable, please hit that like button and leave a comment with your thoughts. And don't forget to subscribe for more deep dives into the technology shaping our future. Thanks for watching.